Okay, so now we're going to go ahead and find the x-coordinate of the vertex. You can't just find the vertex that easily. Okay, so now that we have the two roots, should know that the x-coordinate of the vertex, you need to add up both roots and divide by 2. So I'm going to go ahead and do that. My first one is -2 plus square root of -5 divided by -3. We're going to go ahead and add -2 minus the square root of -5 over -3. And we're going to divide all of that by 2. Remember that positive square root of -5 minus square root of -5 cancels each other out. So now we're left with -2 plus -2 and all that over -3. And I'm just going to go ahead and change that division by 2, looking at a little bit different. Okay, makes it a little bit easier for me, and I'm just thinking it might be the same for you. -2 plus -2. Whoopsie daisy. -2 plus -2 is -4 over -3. When we divide, we actually have to multiply. When you have two negatives, they become a positive. So -4 times 1 is -4, but we know it's going to become positive since there are two negatives over 6. We have to reduce this all the time. And this is 2 over 3. And remember that trick that I showed you earlier? If you take a look over here, yes, I know it says -2 over -3. However, if you take those two negatives and you divide them, they become a positive. So that trick applies to this example and every example for that matter. So it's a lot easier to just write the x-coordinate of the vertex if you remember that trick. You don't actually have to show all of this work for the x-coordinate of the vertex. Since this is only the x-coordinate of the vertex, we now need to find the y-coordinate of the vertex. So we'll go ahead and write that down on the side here. I'm hoping that you're doing this on a sheet of lined paper again, since there's not very much room. And to find the y-coordinate of the vertex, remember that when we already have the x value, we can just sub it in to our equation, the original equation that was given, which is -3x squared plus 4x minus 3. So we change our x value to 2 over 3. And we start by doing the work. So when you're doing this kind of work, you have to do your exponents first. Okay, and we do have an exponent of 2 over 3 to the power of 2. 2 over 3 to the power of 2 means 2 times 2, which is 4, and 3 times 3, which is 9. I'm going to go ahead and put an over 1 with the 4. Multiplying fractions, 4 times 2 is 8, positive 8. 1 times 3 is 3. Now I can multiply this fraction if I put it over 1. -3 times 4 is -12. 1 times 9 is 9. Remember that I want to put the -3 over 1 so that when I add these fractions, it'll be easier. So I can't just add these fractions as is. We need a common denominator. That common denominator will be 9. So to make the second term 9, we multiply the top and the bottom by 3, which gives us 24, not over 3, 24 over 9. To get 9 for the third term, we have to multiply by 9 at the top and the bottom, and that makes it -27 over 9. So now, -12 plus 24 is 12, and 12 minus 27, I always like to check, it's -15 over 9, but again, this reduces to -5 over 3. And this is the y-coordinate of your vertex, so you can just go ahead and write y here if you want. Since we have the x value and the y value, we can say therefore the vertex is, because the vertex is it's a coordinate, so 2 over 3 and -5 over 3. Again, leave it all as fractions and roots and all that good stuff until you graph, but that's the original format. Okay, so go back to the question just to make sure, because there's a lot of stuff here to find. We found the x roots by using the roots formula. We found the y root. We found the vertex. and we're going to go ahead and graph. So in order to graph this, I told you earlier that you can't actually calculate the square root of -5, and I'll show you what actually happens on my calculator. So I'm going to put -5 on the calculator, and I'm going to try to do the root. And it says invalid. And again, it's impossible to calculate the negative square root of something without using imaginary numbers. And that's not something you need to know, but you do need to know that when there are no roots, it's not going to cross the x-axis. So when we go to graph this, go ahead and do your x-axis and your y-axis, and then we'll come back and finish up the graph. Since I know the vertex is sitting at 2/3, which is 0.66666 until you decide to round it. So I'm just going to write that down. Okay, approximately 0.67, comma, not quite sure what -5 divided by 3 is. So I closed my calculator by accident. So -5 divided by 3 is -1.6666. So I'll just round the same way, 2 decimals. At this point, it doesn't really matter because you're estimating where it goes anyways. So going back to the graph, I need to go to 0.67. So I haven't scaled this yet, but I think I'm going to scale it the same way as the other one. So every second 1, 2. Okay, that's my x-axis. So remember that I can't draw my roots because they don't really exist. But I can draw the vertex. So 0.67, just gotta look at it again. 0.67 is right over here, right after 0.5, and -1.67. So that's about right here for that coordinate. Okay, I'm just gonna double check that. 0.67 for x and -1.67 for y. So there's my vertex. I'm gonna label my vertex in fraction form, so it was 2/3, comma, -5/3. We do have a y root, and our y root, I believe, was -3, if I'm not mistaken. I'm just gotta find it with all this mumbo jumbo. There it is. Y root is 0, -3, so 0, -3. Okay. Now, because you have no roots, the parabola is actually open downwards, because if you open it upwards, it's going to cross the x-axis. So we're going to go like that and make it just about symmetrical as you can. You're going to label your y root as 0, -3. Then you'll label that equation. So this is a lot of work. Okay, but you have to know how to do it, and we're not done yet because we still need to find the equation for the axis of symmetry. Okay, so therefore the equation for the axis of symmetry, remember it's an equation, and it's an equation for a line that goes straight through your vertex, and because it's a vertical line, the equation is x equals, and I like to think that's because there's an x in axis, so it's equal to x equals 2/3, because that's the x value of your vertex that we can find right over here. We need to find the domain and the range. The domain, again, as we spoke earlier, we know that it's x element of real numbers for any parabola that is opened up or down. And then the range, we're going to start by doing YER. Okay. However, there's some conditions here. It's only the values that are less than or equal to -5/3. So it's all values that are less than or equal to -5/3. It's not greater than, because that would be a parabola opened upwards. It's less than or equal to your y value. Okay. So there's the domain, the range, and the axis of symmetry. So now the supply will be giving you the homework. There's quite a few questions that you have to do this, so get your graph paper and have fun.